Hello, this is a video for EDX Statistics 1. It is the second video in this series and it will cover the mean and variance of a probability distribution. First of all, we're going to talk about the mean. Another way of talking about the mean of a distribution is to talk about the expectation of it, and these two terms are used interchangeably. This is the formula for the mean. As you can see, we need to find the sum of all the outcomes x multiplied by their associated probabilities. Compare this to finding the mean from a frequency table, where you're multiplying your values x by their relative frequencies. And if you just exchange relative frequencies for probabilities, you'll have your formula. The mean is a measure of central tendency. It is an average, and it is also possible to find the mode and the median of a distribution as well. The mode would be the most probable outcome, and the median, the outcome where 50% of the time you get that value or greater, and 50% of the time you'd get that value or less. Here is the example from the previous video. We've already calculated that k is equal to 1/30th, so we can find the relevant probability simply by substituting into that formula. In order to calculate the mean, it often helps to put the probabilities into a table. So we already have the probabilities for 1, 2, 3 and 4, and I've entered those into the table now. In order to calculate the mean, you can see by the formula we need to multiply together the value x by its associated probability and then add those up at the end. So if I just do that now, I get 1 times 2/30ths, which is 2/30ths, 2 times 4/30ths, which is 8/30ths, 3 times 8/30ths, which is 24/30ths, and 4 times 16/30ths, which is 64/30ths. All we now need to do in order to find the mean is to add up those values. So there they are, typed up. If we add those together, we get 98 out of 30, or 3 4/15. So it's always worth asking yourself the question at this stage is that a sensible answer? Bear in mind it is an average, it's a measure of central tendency. You would expect the answer to be somewhere between 1 and 4, somewhere in the middle of that. Now you can see that this distribution is weighted towards the higher end, that 4 is the most likely outcome, so you'd expect the answer to be closer to 4 than to 1, and so we've ended up with what looks like a sensible answer. It's worth noting here as well that 4 is the mode, being the most likely, and 4 is also the median in that 15/30ths are above it, and 15/30ths are below that value as well. In the same way as we've defined the mean, it's also possible to find the variance of a probability distribution. So here's the formula for the variance for a data set. Now we can manipulate this like we did for the mean in the same way. If we just consider f over n to be the relative frequency, then we're multiplying x squared by this value, which we can think of as the probability, adding those values up and then subtracting the mean squared. So for a probability distribution, you've got this formula. Now, a nice way of being able to remember this is to realise that this first term is simply the expectation of x squared. So in the same way that you find the expectation of x, multiplying x by its associated probabilities, the expectation of x squared is multiplying x squared by its associated probabilities. And so you can remember the formula like that. So going back to returning 3, 2, 1. So returning to our previous example, where we have the mean already calculated, what we're going to do now is calculate this expectation of x squared. So for each of these probabilities, I'm going to multiply this value squared by its associated probability. So 1 squared times 2/30ths is simply 2/30ths. 2 squared times 4/30ths is 16/30ths. 3 squared times 8/30ths will be 72/30ths, and 4 squared times 16/30ths will be 256/30ths. We now need to add them up because we're asked for the sum of these values, so that gives us 346/30. And then to find the variance, we're going to subtract the mean that we calculated before squared from that value. So here we have it, 346 out of 30 minus the mean squared, and as you can see this gives us 194 over 225. It is also possible to find the standard deviation. All you have to do is square root the variance. The final thing to say is that for certain distributions, such as the discrete uniform distribution, it's possible to find a general formula for both the mean and the variance and then use that rather than the methods we've described in this video. And we're going to cover that process for the discrete uniform distribution in the next video. So that's the end of this video. The next video is about the mean and variance of the uniform distribution.